shit. I hope the changes are reflected. Okay. Okay. Let me check. Yeah. So changes are reflected. And okay, so today we are going to solve this problem, minimal grid path. So we are given that an n cross n grid. Okay, first let me make a new file, control n, save it as stream 45. Okay, just going to copy this, paste it. We might need the mod here, so 1 2 3 4 5 6 7 8 9. Okay, so the template is ready. We are given an n cross n grid whose each square contains a letter. Okay, n cross n. You should move from the upper left square to the lower right square. You can only move right or down. What is the lexicographically minimal string you can construct? Lexicographically minimal string that can be constructed. 3000. That means n square only. So we have the input. We have a grid A, C, A, B, A, B, C, B, A, B, C, A, B, D, A, B, B, A, and again double A, C, A, C, A. So we can only move right or down. So our movement is limited, but it also allows us to narrow down which algorithm we can use. So if we could go all the 4 directions, then it would have been a graph question. But since we can only go 2 direction, and that is also very convenient actually, because since bottom up solution also works that way. So yeah, so we can use a bottom up 2D DP here. Okay, you should move from the upper left square to the lower right square. You can only move right or down. Okay, so if we have a 4 cross 4 array and 4 cross 4 matrix, then the string that we can obtain is 4 plus 4 minus 1, that is 7 length. Okay. 7 length string, right? And movement, if we start from this one, then we have an option of going to right or down, but since this is the minimum, so we'll go here. Okay, from here we again have the option of going to right or down, but since this is the lowest lexicographically minimum, so we'll go here. From here we have two options, either go to right or go to left, so we can try both. Okay, so if we try both, then what is the okay, so suppose we went to this down path. Okay, so from the down path we have T or A, so obviously we'll go to A, and from here we can only go right, so AC. Similarly, so the string that we have is A, B, A, C, A. This is the string that we have. And if we went to the left position, so the string will have is A, B, C. Oh, sorry, one A is there. So the string we will get is A, B, and C, A. So the string we get is A, B, C, A. So the lexicographically smallest is this one. So AAA BACA. AAA BACA is the answer. I'm thinking of how to compare these strings in DP matrix, because we can do or also no, yeah, we need, because we have multiple options at some point. Suppose if we change it all to a number, convert it all to numbers, then also we will be getting the same thing only. So how do we check on the DP for the string is lexicographically small or not? So for 1 cross 1, let's break down the problem. So for a 1 cross 1 uh, matrix, we only have one option. Okay, for a 2 cross 2 matrix, there can be there are three basically choices. First is something like this, second is something like this or whatever, third is something like this, okay, let's just say we have something like this. So here we need to compare which one is smaller. So obviously this one is smaller, so we'll go this way, and from here there is only one part to the bottom right, and that is this one. So the lexicographically smallest will be AAA. Okay, lexicographically smallest will be AAA. I'm not sure how the subproblems will depend on each other. Because you see, if we have a we add another layer to it, it's basically a 3 cross 3. In that case, the whole answer will change, and it will not be dependent on the 2 cross 2, right? Or will it? Okay, so for this, okay, so for to include this character, we need to check for three things, right? What is the minimal, what is the lexicographically smallest in till here, what is the lexicographically smallest till here, or what is the lexicographically smallest till here. We have to check this for solving for this. Okay, so till here lexicographically smallest is AA, till here lexicographically smallest is AB, and okay, so we cannot do this, we need to check for this two only. So we can see that the in between both the strings, this one is the smallest, so we'll take that one and then we'll add the current value. So till this we have the minimal string as AAA. Okay, similarly here, what is the minimum till here, till minimum till here, and we'll have the minimum string as ABA, and here also AA, ABA, and we'll have AA. If we extend it, okay, so if we have A, B, A, let's say D, C, A, B, D, again A. So we know the minimum string till this is AAA. Okay, but minimum string till this is AAC. It will be AAC. Minimum string till this will be A. Okay, and minimum string till this is A, B, B. Minimum string till this is basically A, D. So we have to if we have to choose for this one, right? we have to choose for this one, so it will be nothing but a. So we'll add the last one and it will be quintuplet of a. Okay, so I kind of get it. So for if we have our dp as dp I j is equal to we can have minimum what is it, lexicographically minimum. I'm just going to say it minimum string till minimum string till ith minimum string till ij cell. So the transitions will be dp of ij will be nothing but minimum of dp of dp of ij will be nothing but we have the matrix, right? So matrix ij plus or rather minimum of whatever we have from the left and the top. So left we have I j minus 1 and top we have I minus 1 j. Okay, and then we'll concatenate the current string mat ij. This should be the transition. How we are going to compare these strings we'll see. Okay, so this is the transition, simple. What will be the base case? Base case obviously dp of 1 1 is going to be the is going to be this mat 1 1. Yes, so yeah, I think this is it. Maybe I don't know if we can have string in the dp, or maybe we'll have to go around it, do something. Okay, let's see. So we'll have a what vector of string. What is the input here? Yep, vector of string, and we'll say it grid 4, so n plus 1 and we'll take input as n. We'll take an input and we'll take the string input. Okay, now here is the thing. Can we store string in DP? Of course we can. So vector string DP, and the size will be n+1 only. n+1. Oh, sorry. Vector string n+1, and initially all of it will be null character only. And we know that DP11 I hate it. I hate this thing. Okay, so DP of 0 0 will be grid 0 0, and for and we'll go to tell this. Okay, for int j is equal to 0, j less than n, j plus plus, if I is 0 and j is 0, so we don't need to. Okay, then dp ij is basically grid ij, but it is string, right? When it would be okay, we'll see. There's definitely going to be some error here. Okay, we'll debug it later. Else I think there is we can compare. So yeah, we can compare. So minimum and maximum will also work. So what do you want to do? So maximum till this will depend on this and this only. So if I minus 1 is greater than equal to 0, then dp ij is okay, we'll see. dp ij with in the first condition we won't put any minimum here. We'll just give the default value to this ij, plus we have the grid ij, and if j minus 1 is greater than equal to 0, then in that case we'll do dp of ij is equal to minimum of dp of ij and dp of ij minus 1, and then we'll add grid. Okay, this thing. We need to be sure that okay, instead of adding it, I will add later. We'll just set this thing here, and after doing this we'll just add dp of ij plus equal to grid ij. Okay, this thing is this looks good. Okay, so we have this, and I think it is done. And we'll in the end we'll just see out dp n-1 n-1 dot size, and then we'll see out dp n-1 n-1. Let's see. Error for, oh wait, how and why it is 4? Oh, okay, we don't need to triple A BSc. Okay. 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 So why is it not including the first character? Let me output the 0 0 value. Okay. What about 1 1? Well, okay. Else if I greater than 0 and j greater than 0, in that case we'll have dpij as minimum of dp I minus 1 j dp I j minus 1 plus grid ij. Else if I greater than 0 only, plus grid ij. Else for all cases. I mean, there's only one case that j is greater than 0. And for that we'll do this. Okay. So the problem is nearly solved. We don't need the size. What the fuck? Wait. I can't comment this. Why? What happened? Okay. Now I am able to. Sublime be bugging sometimes, so okay. Stream 45 first submission add 20 minute. Fuck. Okay. Memory issue. I forgot there could be memory issue. Okay. Memory and TC issue. Because comparison of those things can be very expensive. So so what we need to do is I'm trying to think of a way we can transform this question into something feasible. For example, instead of storing it, can we do something like LCS? Wait, fuck. Sorry. Where is this? Okay. I'm not sure, bro. Even if we have a string of length, okay, so it will be like 3000 times 3000, so 6000 characters. It is feasible. Yeah, it is feasible. Maybe we can try to do instead of 2D we can maintain 2 dp of one like linear dp. Okay, so let's try to do it with 2 dps. We have vector of string, that is previous, it will be of size n, and initially with this only, and we'll have a we'll have this only, and we can have a vector string current, of course of size n in this. So when we do this, so we are doing this current j is grid ij. Similarly here we are doing current j, and it is nothing but minimum of previous j and current j minus 1. Okay, here also it is current j, this is previous j, okay, and here it is current j, and this one is current j minus 1. Okay, and lastly we'll do previous is equal to current, maybe yep. Okay, and in the end we'll print this. Okay, oh sorry, previous okay, this runs, but I'm not sure if it will work here, because we can still have 3000 times 3000. Okay, TLE, see, we can still have TLE because of the comparisons we are doing, because of this one only. Instead of you know no, maybe they are different. We need to check it. That is the issue, na? This thing only is causing a whole TLE issue. Only this thing. Holy shit, it is. He's using all the STL functions that I've only seen, like transform, standard views, declare type. They are not sure themselves. Okay, CS primer. Wait, is this subscribe? What is CS primer? All the AI pictures, bro. Okay, is it a course website? Yeah, looks like it. Okay, this is not it, huh? Okay, see, code forces, maybe it has some hints for us. Okay, this is not the one, but I think we should search for the manual cut path. The most obvious DP is being the lesser one if we start the cell. Okay, similarly. Okay. There is no solution for it. 7 months. So yeah, this question is new because if it was there, I would have solved it. I would have tried to solve it. It's a new version, and it is a good question actually. It's compression. Okay. To calculate some diagonal, we will take each cell and sort them according to It is very confusing. I can understand this one though, but compression, Enter somewhere else. Wait, what? Okay. So we have n plus 1 diagonal only. Was children as listening. Login. Yeah, I got it, bro. But there's no solution. No one has solved this problem. Why? I don't think. I mean, yeah, this guy. Damn, he solved it. Oh shit, bro. I appreciate it, man. Holy shit. This looks so intimidating. Okay, he did a counting sword. And here he has a 2 DDP. And I assume this is the input. Okay, input. And okay, so he's going from, this is the diagonal, and he's going from the last diagonal. Okay, so he has an array of size 4 max. I mean imax maximum okay, so I think it is diagonal. Okay, he is collecting the diagonal elements in an array. Okay, then he sorted it. Okay, so what is v1 v0? Okay, k must be the base, I think. I don't know. Okay. ID is -1, and for vq. Okay, we'll solve this problem in last. It's so damn. I don't want to solve it. Okay, what is it? You have n coins with certain values. The task is to find all money sums you can create using these coins. All money sums. 6, 5, 11, 12, 13. Okay, so we have only one coin. Hello. Okay, so we have only one coin, and we need to create all the possible summation money sums. And it will be a sorted. Okay, need a sorted list as well. Okay. Um, we just want the combination only, right? So I think this can be done using recursion, but this n is 100, yes, will not work. So if I okay, we need different subsets and then their summation. Solving this directly in a 280p. 10 to the power 5. Okay, so we'll have a DP of size 1000. Okay, so we'll loop in that and try to create the sum. Kind of like a target sum, and it should work because okay, yeah. So every element will be a target sum, and we'll see if we can make it using these coins. Okay, so what I'm suggesting is this. Okay, if I need to this problem official solution is kinda complex. We will solve it later. Okay. Next is money sums. Money sums. Okay, so we have n coins. We have n coins, and each coin is, and we have xi, which goes from 1 to 1000. So this can be like a target sum. For each x, using n coins. Okay, so we'll have a loop basically. So dp of I will be true. If okay, it will be a 2 dB, I think. So for if we when we had a single target, right, we would need at least n cross 1 cross n dp, basically linear dp, and in that what we did was basically all the elements. Okay, so we ran a loop from 1 to n. Okay, so we ran a loop from 1 to x actually, and for each coin we made a choice whether it is possible to create this sum using the coins. Okay, so I think this will work like something like this, that only. Okay, let's see what the dp will look like. So I think our dp will be like this, dp I, and here it will be j, and it will basically be boolean dp, I think. Okay, so basically, is it possible to create some I using first j coins? Okay, how will the transition work? So we have the money, right? So if we run a loop and we don't want the coins to get repeated, so we'll take the coins outside, and then again coins will be outside, the money will be inside, and we'll check if the money value is, if the target sum value is greater than the money value, and if it is, then we'll subtract it and try to search for that in the dp. So can we make the remaining sum using the remaining coins, something like that. So for okay, so I'm trying to come up with a transition. Okay, so dp of we have the state here. Okay, we have the state here. So well, I think this can be done with. This can also be done with a single. Yeah, I think we can do it. We don't need a 2D TP. So let's say we have a DP of single state. So that will be number of ways. We just want to make choose whether it is possible or not, right? So yeah, is it possible to create some I? Okay, and then dp of I will be dp of I or dp of I minus the coin value. If I minus coin is greater than 0, else we have that dp of I is nothing but dp of I minus 1 or not. I just need this one. If I minus coin greater than equal to 0. Yeah, let's see. Okay, this question is giving me a lot of tension. Not the money one. Maybe we can solve it in one try. Who knows? We may be wrong. Maybe. N and X. Vector int X, and what is the size? Basically n plus 1. Should we go for n plus 1? Okay, n plus 1. For int I is equal to 1, I less than equal to n I plus plus, we'll do a cn x xi, we'll have a dp size will be n plus 1 only. No, it will not be n plus 1. What is the sum? Oh no, bro. The sum for 1000 numbers. If you want to check, we have to check for all. Right? Let's target sum for all. Yeah, okay. We actually, what is it? 1000 into 500, right? 1000 into 500. What will it be? 10 to the power 5, 500 10 to the power 5, and then we have 100. And okay. So dp will be 5 into 10 to the power 5. So 5, 1, 2, 3, 4, 5. All initialized to 0. What is the base case? Of course dp of 0 is 0. If we don't have the target itself, we cannot make any sum. Okay. So for int I is equal to 0, 1, I less than equal to this 5001 I plus plus, and for each we'll check for int j is equal to or rather for auto c in coins for x, if I minus c is greater than equal to 0, then we'll do dp of the number I is dp of I, or dp of 0 should be 1 then, I or dp of I minus c. sorry and count is equal to 0 for auto I in dp, and if I is greater than 0, then in that case count plus plus, and similarly for auto I in dp, if I greater than 0, okay, answer dot push back. Okay, no, we cannot do it. We need to do it old fashioned way. Int I is equal to 1, I less than equal to n into n by 2, n into n plus 1 by 2. So we would need okay, we would need more than this. Okay, n into n plus 1 by 2. And I plus 1, I plus plus. We can actually do it n into n plus 1 by 2. Should we? Okay, I think we should. N into n plus 1 by 2, and we'll do 1 plus. Similarly here. Okay. Okay, copy, paste and run. 2, 4, 5, 6, 7, 8, 9, 10, 11, 13, where? 4 into 5, 20 by 2, so only 10. Okay, so we are not going till all the numbers. Okay, we need to do it 5,000 only. 5,000. 1, 2, 3, 4, 5. 10 to the power 5. We'll do 5. Similarly here. Okay. Think you've done made a mistake. Yeah. Aside from 0, nothing should be there. Yeah, we made a mistake. We should not repeat the coins. Yep. Here we were repeating the coins. Not and, it is or. It is and. Okay, so let's try run it. We have the first coin, that is 4. Then we are running from 1 to 13. Okay, t is basically 13. So we are running from 1 to 13. 1 we cannot make, 2 we cannot make, 3 we cannot make, 4 we can make, so 4 will be plus 1 or basically 1. 4 will be 1. dp of 4 will be 1. 5, 4, 6, any other we cannot make using this coin. Okay. Using coin 2, what sum can we make? 1 we cannot make, 2 we can make, 3 we cannot make, 4 we cannot make, 5 we cannot make, 6 can we make? 6 minus 2, 4. So dp of 6 will be dp of 6 minus 2, that is 4. dp of 4 is 1, so it should be 1. Okay, that is done. Now again 4 we cannot make, nothing. Using 5, what can we make? Using 5, we have 0, 1, 2, 3, 4, 5. 5 we can make. 6 can we make? No. 7 can we make? 7 minus 5 is 2, so dp of 2 is 1, so I think it should be 1, so it should be true. Yeah, so it should be true, I think. So 7 we can make. Then again 9 we can make because TP4 will be true. So I don't see why it is not working. See, what I'm trying to do is here 4, 4, 2, 5, 2, right? So let's try to run this loop. Okay, let's run this loop. Let me copy it. Can you copy it? Paste it. Okay, so this is the loop that we are trying to. How do I move it? Okay, so we have it here. So for C next, so first we will be having coin 4. So we have coin 4 and we are going from 1 to T, and T is nothing but summation of all these, which is T is what? T is 4 plus 2, 6, 5, 11, 13. So we have 13 blocks here. Okay, let me write it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so when there is this is so when it is for when it is number 4 coins chance, we have this is 1 because it is the base case, we can make it. Okay, and I minus C, so basically this thing is I, this is I and this is C. So I minus C, let's see, 1 minus 4 is not greater than equal to 0, this is not also greater than equal to 0, this thing is greater than equal to 0, so this can be dpi, and that is dp4 is equal to 4 minus 1 and dp0 here, it is 1, so this will be 1. Okay, this will be 1. Then 5, 6, 7, 8, nothing will work. All of these are because all of these are 0 only. 8 all, so using 4 we can only make 4. Okay, because that is also the case. If we have only 1 coin, then we can make only 1 coin. Okay, using 2, now we have 2 as well. Cannot make these, but still this is 1. Okay, we cannot make this, but still it is 1. Nothing, yes, we can make it, so it will be 1. It will be 1. It will be 1. It will be 1. Okay. 3 we cannot make it. 4 we can make it. So it is also 1, because we already have that established that 4 can be made using a number 4.5. We cannot make it. 6 minus 2 is greater than 0, equal to 0. So dp of 6 will be dp of 6 minus 2, that is 4. So dp of 6 is essentially equal to dp of 4, which is equal to 1. So this is also 1. 7 we cannot make it. 8, 9, 10, nothing, we cannot make it. Now it is 5's turn. Okay. 0, it's still 1. We have this as 1, this is 1 as well. We have this one as well, and we have this one, and we have this one. 5 will be 1 as well. 7 minus 5, 2 is 1 as well. 8, no. 9 minus 5, 4 is 1 as well. So 9 will work as well. So I think we have all the combination here. Okay. Again, we have now 2. Wait. Okay. We again have 2 here. So this will be 1 again. This will be 1 again. This now 4 is already 1, so it is also 1 again. 5 is 1. 6 is also 1. 7 is also 1. Now for 8, can we make 8 minus 2 6? Yes, 6 can be made. So this will be 1 as well. 9 is already 1. And also for 10 minus 2, can we make 8? Can we make 8? Yes, we can. Yes, we can. Can we make 8? But not using these coins, because it is already being used here. We need a second. Dimension. Yep, we need a second dimension. So even if we try to do the opposite way, okay. So right now we have I in the outer lip. Okay. If we want to do it like this, then also it is the same. Yep. So yeah, we need a second dimension. So let's go. It will be n. All initialize to 0, and then if we have no coin, and if we have no money, then can we make it? Yeah, we can make it. And let's do the base cases. For int I is equal to 0, I less than equal to x I plus plus. Okay, so if we have no money and if we want to create all the sum, then it is not possible, right? So in that case, dp of I and 0 will be 0. Similarly, for int I is equal to 1, I less than equal to n I plus plus. If we have, if the sum is 0 and we have all the money, then in that case, can we make the sum? Of course we can. Okay, base case is done. We run the loop from coins to all the targets. If I minus c is greater than equal to 0, then in that case dp of I and the current coin and the current not coin. Now we will traverse from I is equal to 1, j less than equal to n j plus plus. C will now be changed to xj. And j will be equal to I minus xj, and this is j. And if not, then dp of ij will be this is basically we choose that we choose that coin, right? And if we do not choose that coin, then what will happen? So the answer is same. Can we make the coin using the last till the last element? Okay, so I think this should work. Okay, it compiled. So now we have this count. And we are just going to check if int I is equal to 1 to I less than equal to t I plus plus, if dp of I and the last element, which is basically n, is 1. Okay, so we are going to increase the count. Similarly, and we'll see out it. Should it not be g minus 1? Okay, bro. I admit defeat. I've already solved it, bro. Swear to God. Oh, no. It's the same. It's the same thing, bro. Everything is zero. Oh, no, no. It's the same thing. See? It's just that. It's the same, right? Why are we taking the sum from 0? Doesn't change the fact. What is the value of t here? Okay. So if I put this first, and then put this. And then change anything. Okay, so instead of doing it else, I didn't change anything. Okay, I'm doing everything that I did that time. Okay, go. What is wrong here? What the fuck, bro? Okay, so there was an issue not with my code, but here maybe. So if I did this, oh, okay. Yep, yep. Ah, bro, I'm tired. And there is no change in the code from the last time. It's just copy and paste. I'm actually really ashamed of myself for this. This is also. This is, I think, an easy one, but I'm not in the mood of solving it today. Yeah, it is. I had enough. This problem, minimal grid path, and both of these problems, bro. So irritating. Damn. Yesterday was a good day, I think. I was able to solve the problems without looking anywhere. Yeah, today is just not my day, I think. I actually thought that. Actually, I thought that now that I'm done with the thing that I was supposed to do in my office, I thought that I would stream for like 3 to 4 hours and solve all the problems. Man, these 2 problems, bro, just took away all the energy. Yeah. So you can also see my eyes; they are starting to close of themselves. So okay, so this will be the end of this stream, and I hope that you have a good night and